Hello friends, welcome to my channel. Let's have a look at problem 2030, maximum twin sum of a linked list. So in this video, we're going to share two formats of solutions. So the first format basically is a linear traversal to get node value and then pair from head and tail to form twin sums. And the second method actually uses slow faster pointers and do some reversal. So first, let's look at the statement of the problem, and then let's do the analysis, and finally we share the code. So first, the statement. In a linked list of size n, where n is even, so here the problem statement emphasizes that the length of the linked list, or the number of nodes, will be even. So this is also actually a consistency assumption, because we want to form twin pairs. So the ith node of the linked list is known as the twin of the n-1 minus I node. So here are examples. So we can use here, for example, here 5 and 1 are twin pairs, and 4 and 2 are twin pairs. So the twin sum is defined as the sum of a node and its twin. So given the head of a linked list with even length, return the maximum twin sum of the linked list. So we are interested in the maximum sum of or the twin sum. So that's the main statement of the problem. So let's look at some examples. So in example 1, so we have two twin sums. One is 5 plus 1, that is 6, and the other is 4 plus 2. The sum is also 6. So the return in example 1 is 6. And in example 2, so we have two twin pair sums. So 4 plus 3, that is 7, and 2 plus 2, that is 4. So the return is 7. And in the example 3, so there's only one twin sum, so we return this twin sum. So before we look at the analysis, let's also look at the constraints. So the first one is on the number of the nodes, which is even and in the range 2 to the power, 10 to the power 5. 10 to the power 5 is a decent large number, we'll see, for the length. And the second one is not that essential. That is the range of values for the nodes, which is in between 1 and 10 to the power 5. So with that said, let's look at the method and analysis here. So here are the two solutions. As we mentioned, the first one is a linear traversal. So we're going to get the nodes values, and then we store that, and then we just need to pair them from beginning and also from the ending, so towards the middle, so to form twin sums. So in this format of solution, the space is on, as time is on2. In the second solution, so we're going to save some space. So we're going to use slow fast pointers. So this is actually a very routine technique in linked list. So we're going to use this technique to locate the middle node, and then reverse the linked list to the right of the middle node. Then we just form the twin sums using the two resulted linked list. And in this format of solution, the space is going to be O1, and the time is going to be On. So here is a very quick walkthrough for the example 1. So we have a linked list 5.24 and 4.22, 2.1. So if we are going to use method 1, so we're going to get a list to consist of integer numbers, that is 5, 4, 2, 1. Then we check 5 plus 1 and 4 plus 2. So this is the idea for method 1. For method 2, actually we are going to find the middle and then break this link and then reverse the second half. So we get two linked lists. One is 5.24 and the other is 1.2 after the reverse. So in this case, we just need to check the height of the two linked lists and then continue to move forward. 5 plus 1 and 4 plus 2, right? So it's essentially the same effect, but the second method saves some space. So with that said, I guess we are ready to write the code. First, let's look at the method 1. So we're going to use a method which is space on, and for time is also on, because we are doing linear traversal, right? So for this method, so we're going to use an auxiliary list. Let's call it auxiliary. So it's empty. And then we're going to traverse the linked list. So basically, this is also a practice. Also, let me initialize a variable called n. So at the very beginning is 0. N is going to count the number of nodes in the linked list. So next is basically a traversal using the while loop. While hide, what we are going to do is that we append the head value to our list. So once we put a value to the aux, so we're going to increment this n by 1. And next we're going to reset the head status. So we're going to reset the head to be head next. So this way, after this while loop, we start all the values, node values in the aux list, and also we get the length of the linked list. So as n is even, so actually we just need to make n over 2 sums. So because we know there will be n over 2 twin pair sums, so we just need to return the maximal, right? So for this, because of the values of the node is bounded below by 1, so the twin sum will be always positive. So we're going to reset the result, initialize the result to be 0, and then we get the largest possible twin sum. So this is basically a for loop for I in range n over 2. So here n over 2 is the integer division. And then we're going to reset the state of the result variable, the previous state, and the possible twin sum, that is aux I, then plus aux n minus 1 minus I. This is counting from the beginning, and this is counting from the end towards the middle. So this is one twin sum, and then we compare to get the maximum. So after this for loop, we're going to return the result state. So that's one solution. So let's first do a special case check. Yeah, it passes example 1, I guess. So now let's do example 2, do generic case check. Yeah, it passes all the generic cases. So with this format of solution done, let's look at another one, so which slightly improve the space complexity. So we're going to copy this function signature here, and let's call this one v1. So for this method, so the time is still O1, the space will be O1. So I'm going to split this format of solution into different parts. Let's split into 3 parts. So first one is to locate the middle node using slow, fast pointers. So this is actually a very standard technique. So we're going to initialize 2 pointers. One moves slower and one moves faster. The one moves fast moves twice as fast as the slower one. So when the fast pointer arrives at the end, then the slow one arrives at the middle. So, and I'm also going to use a previous because we want to break some link later. So previous equals none, and slow equals fast equals hide. So this is the initialization of the slow and fast pointers. And then we're going to do the standard while loop condition, while fast and fast next. And the reason we write this condition is that we're going to move fast pointer twice, 2 steps each time. So we need to check fast next next. So we need to make sure fast next is not null. So with that said, first we're going to move the previous forward to be slow, and then we move slow 1 step, and slow next, and then we move fast twice, so 2 steps, fast next. So this is not null by our while loop condition, so we can always do next. So after this, actually we get the middle of the linked list. For example, we get here for the slow, right? So then what we are going to do is that here, let me do some preliminary. So I'm going to break this one. For example, here I will not let for point to 2. So we're going to pre next to be null. So here is actually a break the link. So this is not absolutely necessary, here. But let's do this to make it more clear in logic. So next is that we adjust the pointing. So in other words, we want to do reverse. We reverse this part, right? So for this, actually, we can do this trick again. So we set a null, and then the current is a slow. So the linked list, if we use example 1, so the linked list headed with node 2 is the one we want to reverse. So this is slow, and then basically is a while loop, while current. So what we are going to do, first let's get the current next so that we can use it later. So current next. And the overall goal is that we point the next of current to the previous, right? So the current next equals previous. So this is okay because we have already stored the current next in the first line. So next we're going to shift the current to be previous to be current, and current to current next. So this way, actually, we reversed the second half of the linked list, and the previous will be the head of the reversed linked list. So let's do step 3 now. So step 3 is now the two linked list. One is represented by head, and the other is represented by previous, right? So, and they have the same length. So that's what we want to emphasize. They have the same length. Due to the problem assumption, because the number of nodes in the linked list is even. So then actually we can just check the twin sums. For this, we're going to initialize a result variable. So you can set it 0 or you can set it -infinity, just to make a gap so that we can compute maximum. So then we can initialize two variables if we like. Actually not necessary. So current 1 equals head, and current 2 equals previous. And then we're going to do a while loop to check twin sums. So while current 1, so what we're going to do is that the result is maximum, the result, and then the twin sum is actually current 1 value plus current 2 value, right? And then after that, so we're going to reset the state of current 1 and current 2. In others, moving forward in both of the two linked lists, that is current 1 next, current 2 next. So this way, actually, we finish the computation of the maximum sum and twin sum and doing the necessary comparison. And finally, we can return the result. So this is the second solution format, obviously. So let's first do a special case check. Yeah, it passes the example 1. Now let's do the generic case check. So yeah, it passes all the cases. So that's about it for these two formats of solution. So personally, actually, we feel that the solution using the first format may be more natural to this problem because it concerns only the twin sums. And the second method practice some common techniques like fast slow pointers and reverse a linked list. So both the two methods are sort of routine, I would say. So it's actually good to practice such problems. So with that said, I guess that's about it for this video. Thank you very much.